Now to the last part of this particular chapter, stability of cycloalkenes. As you can see, upon stability we are going to discuss a theory, Bayer-Strain theory. Now Bayer was a German scientist. He said that cycloalkenes I'm talking to you. So the alicyclic compounds having 3 or 4 membered ring, means lesser number of carbon atom in the ring, are less stable in nature compared to 5 or 6 membered, we can say that. Clear? Bayer said that alicyclic compound having 3 or 4 members, that means cyclopropane and cyclobutane, are less stable in nature compared to cyclopentane, cyclohexane in this way. Got it? Now this was said by Bayer. Why he said this? He suggested that the inability of the small ring compounds with was due to the angle strain. Alright, why these are unstable? Because the inability of the small ring compound was due to the angle strain. Alright, as the angle strain is much more, for that particular purpose, this compound are less stable in nature. Now what is angle strain? I am going to come to it. Now this was a theory, was put forward by Bayer, that why they are unstable, that because the angle strain is more, so hence it is, what you can find is that they are less stable in nature. Fine. Now Bayer-Strain, what you can say, strain theory, this strain theory, Bayer-Strain theory is based upon the assumption that when an open chain organic compound having the normal bond angle, like let us say 109.5 degree. Now this angle, from where we got it? It is the bond angle of a regular tetrahedron. Tetrahedron 4. Got it? Regular tetrahedron. The bond angle is 109.5 degree. This one. This is a tetrahedron. Alright, this is not straight, of course, in this way. This is a regular tetrahedron and the bond angle here it is 109.5 degree. You will be studying more about it in chemical bonding chapter. The bond angle is 109.5 degree, this particular bond angle. Alright, this is a regular tetrahedron. Just I give you structure like methane, C, H, 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 H. If you put it, then what is this structure? This is nothing but the structure of methane molecule. We can say that. Methane, ethane, propane, butane, all single bond. Understood? Clear? Regular tetrahedron. So what he suggested, what is Bayer-Strain suggested, is based upon the assumption that when an open chain organic compound, got it, having the normal bond angle 109.5 degree. Now this is an open chain. CH4 is an open chain organic compound. This is a structure I show you just to explain what is tetrahedron. Understood? Don't get worried about that CH4 is again cyclic. No, it is not a cyclic structure. You have seen the dotted line, I have done it. It's not a solid line, dotted line. Just to give you a structural diagram, I have done it that. Otherwise, CH4 is an open chain structure, you know that. Alkene, methane. So, that is an open chain organic compound having the normal bond angle of 109.5 degree is converted into a cyclic compound. When it is being converted, an open chain compound is being converted having a normal bond angle 109.5 degree. When it is converted into a cyclic compound, a definite distortion in the normal angle takes place. Definitely, when you will convert an open chain compound to a closed chain compound, a distortion in the angle is going to take place or not? A distortion is going to take place in the angle. So that angle is known as the angle of strain. That is called as. Again I repeat, when you are converting a normal open chain organic compound having a bond angle of 109.5 degree. Why I am taking 109.5 degree? Because first is alkanes. Now open chain organic compound is alkanes. Alright, so alkanes, the single bond we can say. Clear? So in this way, when you just what you can say convert it into a closed chain compound, into a cyclic compound, then what you find is that definitely the bond angle is going to change. So there a strain is being, what you can say, developed in that particular bond angle. Clear? So that particular strain, a definite distortion. Distortion means the shape of the molecule is going to change, and a strain, a force is going to develop in that particular angle. So that is nothing but known as angle of strain. That particular. Clear? It develops a strain in the molecule, that is called as angle of strain. Now let me explain you. Then you will come to know, otherwise you may not know. Let us say this angle is 109.5 degree, let us say. Let me write it outside. 109.5 degree this angle is. Now what I am doing is that this is an open chain. I am converting it into nothing but a closed chain compound. I am converting it. This one, a closed chain compound. I am converting it. This one is an open chain. I am converting it into a closed chain compound. Of course the line is there. Alright, now let me draw this as a dotted line because this is not required now. This is not the actual compound. This is the actual compound which I have drawn it in the solid line, you can see. So I convert it into a dotted line, you can see. Clear? So this angle was 109.5 degree. Now this is a cyclopropane I have done it. What is the angle here? Definitely this angle is 60 degree. This angle, definitely you know that 60, 60, 60, 180, isn't it? 60 degree. This angle is 60 degree. So what is the other two angle? It will be equal. 109.5 minus 60 by 2 you do. Other two angle, this two angle, this two angle. Alright. So the other two angle will be nothing but it will be around 20. How much? That is how much it will be? 109.5 minus 60, it will be 22 by 2, 22.4 degree. Yeah, correct. 22.4 degree. So there develops a strain, you can see. It is converted from 109.5 to 60 degree. What you can say 60 degree. If I convert it into a butane, then the angle will be how much? 90 degree. The angle will be how much? 90 degree, na? Instead of 60 degree, the angle will be how much? This angle is how much? It is 90 degree. This angle is 90 degree. So you can see a strain developed. Then only it is being converted. An open chain compound is being converted into a closed chain. Then definitely a strain is developed. Strain means a force is developed here. Then only it is being converted, and that angle is known as angle of strain. That is known as angle of strain here. Now, what we find is that Bayer assumed that the cyclic rings are planar. Cyclic rings. This is cyclic rings. They are planar in nature. He assumed. Mind it. I am using the word. He assumed they are planar. Planar means two-dimensional. Alright. Assuming that the rings are planar, the amount of strain in various cycloalkanes can be expressed with the angle of deviation. As it is planar. Alright, so the amount of strain which will be developed from converting from 109.5 to 60, 90, a strain will be developed. Different strain will be there in different compounds. Okay, so that can be expressed in terms of angle of deviation. That how much it is deviating from 109.5 to come to 60 degree. How much it gets deviated? From 109.5 to 90 degree, how much it's getting deviated. Alright. So it is being calculated by angle of deviation. What is the formula? Angle of deviation half into 109.5 minus alpha. Alright, this is angle of deviation. D stands for angle of deviation. Now what is this alpha? Alpha is the inner bond angle in the cycloalkane ring. Alpha is the inner bond angle, 60 degree, 90 degree, that is alpha. Alright, what I said? Inner bond angle in the cycloalkane ring. The cycloalkane ring, so inner bond angle is how much? 60 degree. Here the alpha is how much? 90 degree. Understood? Clear? Fine. In this way. Now, next is what he concluded, is that the angle of strain is directly proportional to D. Angle of strain is directly proportional to D. Means deviation. And if deviation is more, angle of strain is also more. Definitely. If deviation is more, if D is more, angle of strain is also more. Similarly, he said that, one more thing he said, angle of strain is nothing but this is inversely proportional to the inner angle. This is 60 degree, 90 degree. Inversely proportional to, that is alpha. We can say that. Now this is inversely sign, understood? Inversely proportional to alpha. We can say alpha. Clear? Acha. One more thing is said that, now this one it is not so, because already I have said you about the deviation. Angle of strain is inversely proportional to alpha. Now I will talk you another one. That is, he said that stability, I think it's clear to you. Angle of strain is directly proportional to D, that is angle of deviation, and angle of strain is inversely proportional to alpha in its inner angle. Now stability is inversely proportional to the angle of deviation. Means more is the angle of deviation, less is the stability. Or less is the angle of deviation, more is the stability. This is very, very important. You need to understand. Now, in case of, now let me come to cyclopropane first. So, what you got? Alpha is 60 degree. And if you calculate the angle of deviation, I have remembered it. This is nothing but 22.4 degree. I remembered it. So, I am telling you. We got it, the angle of deviation to be as. Fine. Next is, if, what you can say, for the cyclobutane, the alpha is 90 degree. So, angle of deviation will be nothing but 9.4 degree. Angle of deviation is 9.4. This is 9.4. So, stability is more. Here it was 22.4. This is 9.4. Deviation is less. Stability will be more. So, that means cyclobutane is more stable than cyclopropane. Are you following? This is angle of deviation. In case cyclopropane is 22.4. C. And in case cyclobutane, D is how much? It is nothing but 9.4. Which is less? 9.4 is less. So, if the deviation is less, stability will be more. So, hence, in which case it is 9.4? Cyclobutane is 9.4. So hence cyclobutane is more stable than cyclopropane. Now it is clear. Now it's clear. Now next. After that, let me come to cyclopentane. Now you see what happens. Now in case of cyclopentane, the angle is cyclopentane. Alright, angle is how much? Cyclopentane is angle is 108 degree. You know that? 108 degree. Polygons. Alright, it is 108 degree. So the D will be 0.44 degree. You will be getting the least. After that, what happens? In case of cyclohexane, it becomes 120 degree. Alpha becomes 120 degree, isn't it? So D will be negative. Mind it, D will be negative. You can find it out in your home and you can see it. Clear? In case of cyclohexane, cycloheptane, same thing. That is, alpha will be definitely in case of cycloheptane, cyclooctane, you can see, you have read it, that is going to change. The alpha is going to change, that is nothing but 2n minus 4 into 90 by n. If you do it, you will find it out, the cycloheptane, cyclooctane, what it will be. But what I mean to say is that from cyclohexane onwards, listen carefully, the D will be negative. It will be negative. So in which case is the least? Cyclopentane is the least. Alright, cyclopentane, which I said you how much it is. In case of cyclopentane, it is nothing but 0.44 degree. The D we got it. So less is D, more is stable. So out of cyclopropane, butane, pentane, which is stable? Pentane is stable. That is only Bayer said that. Okay. Now Bayer said that. Now Bayer added it. He made a mistake here. Bayer said that cyclohexane is more stable than less stable than cyclopentane. Because he assumed to be planar, na? So he said that cyclohexane is less stable in nature than cyclopentane. Less stable. Why? Because it's a bigger ring, so hence it is less stable in nature. But actually the opposite. Cyclohexane is basically more stable in nature than cyclopentane. That we find it out now experimentally. Once again I repeat. What we got for cyclohexane? The value of D to be as negative. So based on that particular basis, Bayer said that cyclohexane is less stable in nature than cyclopentane. The most stable is cyclopentane because that is having the least value of D, 0.44 I said you. Alright, so hence this is more stable. So cyclohexane less stable, bigger ring. So more strain. For that purpose it is coming to be negative and it is less stable in nature. He said that. But it is wrong. Now we see that cyclohexane is more stable than cyclopentane. Alright, so this was not known to, that is Bayer, this particular thing. So this is a drawback of the Bayer strain theory. Here he went wrong. Alright, how he came to the angle of strain and all these things. Now, actually, cyclic compounds, they twist and bend in order to achieve a final structure. The twist and the bend, they twist and the bend in this way, the cyclic compounds, the single bond, the twist and the bend, and they achieve a final structure. Cyclic compound. Now, next is that what I said, cyclic compound, the twist and bend to achieve a final structure that minimizes the three different kinds of strain and that can destabilize a cyclic compound. To minimize the strain, there are three different types of strain. I will talk to you. To minimize the strain, because if the strain will be less, the stability will be more. You have seen it. If the strain is less, the stability is more. Theory was correct by Bayer, got it. But one place he went wrong in case of cyclohexane and cyclopentane. Otherwise the concept was not wrong. How it can be wrong? So in this way, there are three things, three strains are developed, because when a open chain compounds is converted into closed chain compounds, it twists, it bends, and as a result, three strains are developed. What are those three strains? I did not. Angle of strain already I said you. Angle of strain is the strain that results when the bond angle is different from the desired tetrahedral angle of 109.5 degree. Angle of strain is developed when the desired angle is less than that of the normal tetrahedral value, that is nothing but 109.5 degree. That is called angle of strain. We can say that. Now, Torselian strain. Just I was talking to you in conformers. Torselian strain is caused by the repulsion of the bonding electrons of one substituent with bonding electrons to nearby substituent. Alright, two substituents are there. One is here in the first carbon and the second carbon. So, the repulsion which is taking place between the two substituents, that is called as the torsional strain. Repulsion. It is because the electron cloud of one and electron cloud of the other, when they are coming closer, they will repel one another. Next is the steric strain. Steric strain is caused by atoms or groups of the atoms approaching each other too closely. when the atoms or group of atoms, it may be same atoms or different atoms, when they approach very closely, on twisting or bending, when they approach very closely, when they come very closely, then that strain which is developed, that is known as the steric strain. That is known as steric hindrance, which you studied earlier also, I said it. So we got it angle of strain, we got it torsional strain, we got it steric strain. These are the three different type of strain. Angle of strain is a strain that results when the bond angle is different from the normal tetrahedral value 109.5 degree. Torsional strain is caused by the repulsion of the bonding electrons of one substituent with the bonding electron of another of a nearby substituents. Got it? And steric strain is caused when the two atoms or groups, when they approach each other, when they come closer to each other, then the strain is developed, which is known as the steric strain or steric hindrance, we can say that. Now, due to which, what is going to happen? Got it? We will see in the next one, we will see it.